Good afternoon, everybody. Myself, Daksha Diwan. I am assistant professor in a government engineering college, Gandhinagar. So, welcome to all of you in an active learning lecture on a calculus. Today, we will learn here some more examples of the partial derivative. We know for engineering students, partial derivative is very important topic. It's the derivative that we are taking in a parts with respect to x, y. So more than one variable when in an independent variable, then we are using partial derivative. So let us start the frequently asked question on this partial derivative. This session is exam oriented. That's why we are taking the examples of papers from our GTU examinations. So let us start and we will enjoy this lecture with partial derivative. So look at the screen. Partial derivative. So first of all we will see what is the partial derivative. If z is a function of f of x and y, we write fx xy where fx is a del f by del x. So we can use the different notation which is on the screen, that is the del z by del x. f1 d1x or dxf. If we are taking the derivative with respect to y is fy xy, fy del f by del y. So derivative with respect to its y, so another symbol is a del z by del y and dy by dyf. So this is a different notation to write the partial derivative. The partial derivative of f with respect to x is the derivative of f with respect to x when all other variables are treated as a constant. So when we will take the derivative with respect to x, if we have other variables like y, z, t, then they are keeping as a constant and we are taking only the derivative with respect to x only. So that is the main process. Similarly, partial derivative of f with respect to y is the derivative of f with respect to y when other variables treated as a constant and as other variable behaving as it is for that. So let us start with the example which are mostly asked in our GTU paper. So GTU March 2009 example. This example is very interesting and very important also, because here we are taking the second derivative. So u is equal to log of x cube plus y cube plus z cube minus 3xyz. We want to prove that del by del x plus del by del y plus del by del z whole square of u is equal to minus 9 upon x plus y plus z whole square. So we start our example with solution. Here u is equal to, what is our u is equal to here? Log of x cube plus y cube plus z cube minus 3xyz. We will take the derivative of u with respect to x. We know the derivative of log t is a 1 by t. So here our t is a x cube plus y cube plus z cube minus 3xyz. So take it among, and the derivative of x cube is a 3x square. Derivative of y cube with respect to x is 0. Derivative of z cube with respect to x is 0. And minus 3xyz. Yz keeping the constant and derivative of x is 1. So we have a 3x square minus 3yz upon x cube plus y cube plus z cube minus 3xyz. This is the derivative of u with respect to x only. Samely, we can do that thing with respect to y also. So del u by del y, we are taking the derivative here. So derivative of log t is a 1 by t. So we are taking upon x cube plus y cube plus z cube minus 3xyz. Derivative of x cube is 0. Derivative of y cube is a 3y square. Derivative of z cube is 0 minus 3 x and z behaving as a constant because we are taking derivative with respect to y. So derivative of y will be here 1. So we have this answer. Same thing we can do for the derivative with respect to z. So uz, that is the 1 upon x cube plus y cube plus z cube minus 3xyz. Now here we are taking derivative with respect to z. Therefore x and y behaving as a constant. So derivative of x cube is 0, derivative of y cube is 0, then derivative of z cube is 3z square minus x and y behaving as a constant, derivative of z is 1. So 3z square minus 3xy. So this is our answer of del u by del x, del u by del y and del u by del z. Now we will take the next derivative with respect to x, y and z. So let us see on the screen. First we will take the addition of these three, that ux plus uy plus uz. We know in upon all the terms are same. In the above slide we have in a denominator portion are the same in all that three. So taking the addition of the numerator, that is 3 is common, so x square plus y square plus z square, and minus 3 is common, we have a minus xy minus yz minus xz, and the factor of the denominator is, we know the factor of x cube plus y cube plus z cube minus 3xyz is x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. So cut that upper and lower portion. By the, I think there's some mistake, we can't see the last term on the screen, that is a minus zx. So the remaining portion is a 3 upon x plus y plus z. Now del by del x plus del by del y plus del by del z whole square into u. That is our LHS. We want to find the value of that. So this is whole square. So we can write in a multiplication twice. So first term is del by del x plus del by del y plus del by del z into, this is square, so we are taking the second time and multiplying the u inside. So del u by del x plus del u by del y plus del u by del z. We have the value of that ux plus uy plus uz. That value is a 3 upon x plus y plus z. Now operate each operator on that term. Here we are operating that del by del x. So derivative of 3 upon x plus y plus z with respect to x, that is minus 3 upon x plus y plus z whole square. Now apply the second term, that del u by del y on that 3 upon x plus y plus z. So derivative is minus 3 upon x plus y plus z whole square. Similarly, apply the del by del z on that term. We are getting minus 3 upon x plus y plus z whole square. So this is minus 9 upon x plus y plus z whole square. So that is our RHS and this is our answer. Now the next example from our GTU paper November-December 2010. If u is equal to x square plus y square plus z square raised to m by 2, here the one mistake, we have this z square, then find the del square u by del x square plus del square u by del y square plus del square u by del z square. So the solution of that is u is equal to x square plus y square plus z square raised to m by 2. Taking the derivative with respect to x, we have a m by 2 x square plus y square plus z square raised to m by 2 minus 1. The derivative of x square is a 2x. The derivative of y square is 0. Z square is 0. Now cancel this 2. We have a mx x square plus y square plus z square raised to m by 2 minus 1. So del square u by del x square, we are taking the second derivative, mx into m by 2 minus 1 x square plus y square plus z square raised to m by 2 minus 2. We are taking the power, the front side, and taking the minus power in the upper side. The derivative of again x square is 2x and plus this m as it is, derivative of x is 1 and the another term will be as it is. So we can simplify these terms and we have this answer. Similarly, we can find del square u by del y square, the same pattern, but in the place of x we will have here y. Similarly, we can find del square u by del z square. So here m minus 2, in the place of x we have a z square, x square plus y square plus z square raised to m minus 4 by 2, and same thing we will have here. Adding this 3, we obtain del square u by del x square plus del square u by del y square plus del square u by del z square. We have this answer. So adding all this 3, we have x square plus y square plus z square. So we have increased the term so del square u by del x square plus del square u by del y square plus del square u by del z square. Simplifying these terms, we are getting m plus 1 into m x square plus y square plus z square raised to m minus 2 by 2. So these are the simple examples of only the partial derivative. Now we know the partial derivative is a very vast topic. So we have several rules in that partial derivative. So let us see the more example of that. We have a chain rule and Euler's theorem also. So let us start with the chain rule. First we will see the definition of the chain rule on the screen. Suppose that w is equal to f of xy is a differentiable function of x and y, where x is equal to g of t and y is equal to h of t are both differentiable function of t. Then w is a differentiable function of t and dw by dt is equal to del w by del x into del dx by dt del w by del y into dy by dt. So this is our basic chain rule. Now This is by the picture we can see this thing is very easily. We have a here little bit tree, that is w is a function of x and y, and x and y is a function of t. So w is a function of more than two variable. So on that part we are using del w by del x and del w by del y. But x and y is a function of only the one variable t. That's why we are using del. In the place of del we are using dx by dt and dy by dt. Suppose that w is equal to the function of x, y and z is a differentiable function of x, y and z, where x and y and z are differentiable function of t also. Then w is a differentiable function of t. So we can write dw by dt is equal to del w by del x into dx by dt plus del w by del y into dy by dt, del w by del z into dz by dt. A similar argument for the same thing of del z by del s also. Suppose your z is a function of x and y, is a differentiable function of x and y, where x is equal to g of s and t and y is equal to h of s and t, are differentiable function of s and t both. Then we can say del z by del s is del z by del x into del x by del s plus del z by del y into del y by del s. Del z by del t is equal to del z by del x into del x by del t plus del z by del y into del y by del t. We can understand this rule easily by the using this tree diagram.